Hello guys, how are you? Welcome back. Yanong ha re lebella gore re ka determine the specific heat capacity of a solid ka tsela e ntseng yang akere. So hana re tlhalosa gore heat loss can be reduced by covering with a lid and insulating the tank akere. Yeah, o ka insulate yone this copper block if it's copper. So set up the experiment as shown with sengwe le sengwe se se bonang ha go na hela yana yaanong ha re bua gore go iragala eng se se botlhokwa ke gore lemoga gore heat gained by copper is equal to heat supplied by the heater. Mmeng ha ke gone e leng gore mo ke assumption ke potso engwe tabe ke re what assumption did you make in determining maybe the specific heat capacity of copper? Assumption ke gore no heat is lost. The heat supplied by the heater is gained by the copper, but in reality, rise or energy lost. Again, assumption no heat is lost. So heat gained is equal to heat supplied by the heater, and heat energy supplied by the heater again get power times time. I get power times time. And this is the formula PT, then you get it from here. I get power is IV. Electric power get IV times time. Then now when power times time. I get yes. Yeah, now moving on to determine the specific heat capacity of water experimentally. These are the things that you need. Yes, this is what you need. And this is how you calculate heat gained by water is equal to electrical energy lost by the heater, then warring power times time. So it's the same thing. Topic based the principle of energy conservation. Assuming that no heat is lost to the surrounding, it follows from the law of conservation of energy that heat lost from the body at a high temperature will equal the heat gained by the body at a lower temperature. So again, heat lost is equal to heat gained. Assumption, provided there is no energy lost. Provided there is no energy lost. Right? The solved problem in an experiment, 900 joules of energy is transferred to 3 kg of iron. This is its what? Specific heat capacity. Again, the initial temperature of iron is 25 degrees Celsius. What is the final temperature of the iron? Guys, the data. What is it that you have and what is it that you are looking for? I get yes. So data rona guy. Data rona kiye. In experiment 900 joules. Horari, this is Q is equal to 900. Is transferred to 3 kg of iron. I get M is equal to 3. C for iron is 460. The initial temperature of iron is 25. T I is equal to 25. What is the final temperature? T F. What is TF, guys? What is TF? Yes, what is TF? What is it that we know? From this, we can easily see that the formula that we use here is this: MC change in temperature. The change in temperature, guys. Yes, in nahela yan. Okay, yan. Go na le bana ba ratang go tsenya di-value ha ba tsena ke ta ba etsa today. E ka re ba rata go irana. I think it's much simpler for them. It's much simpler. Ke batla go ngakalla ke ira dilo in a difficult way, but go na le ba ba akanyang gore go motho ka tsele ke ta substitute before we change the subject to the formula. So energy ke 900, ke ra 9000, ta ke 9000 is equal to m ke 3, c ke 4 times 460. Most of my students, they like doing this. So rara hage 9000 is equal to rara hage okay 1 point I think it's inside point 1308 change times change in temperature. Yeah, they like doing this. Whatsoever we divide both sides by 1.38 here. 1308. This cancels out. Then 9000 divided by 1380 and now 6.5217. Yeah, now, but we know that change in temperature so potsa tshwanetse re ipotsa ha ke gore ke re ke buile gore value in positive. I get change in temperature since we're in positive. So what is the final temperature? Final temperature is higher than 25. So what are T minus 25 in naya? T minus 25 because T is a temperature which is higher than 25. So I require 6.5217 is equal to T minus 25. What do? We add 25 both sides, plus 25 plus 25. This 25 cancels this 25. I get, yes, then 25 plus this, what do we get? For our 31.5217 is equal to T final. This is TF, right? So T is equal to T final. The final temperature is, we can round it to two single figures because 25 in a room is 25 point something again. So I rearrange 32 degrees Celsius. So T is equal to 32 degrees Celsius. This is how we work it out. So then the second question here. Second question here, guys, had 100 grams of water in a beaker A at 70 degrees Celsius, right, is added to 300 grams of water at 30 degrees Celsius in beaker B. What is the final temperature of the mixture? Assume there is no heat lost to the surrounding or the beaker. The beaker is the environment, is the surrounding. So concern the heat exchange between mates here. Okay, yes. And this final temperature. The final temperature of the what? Of the mixture. Where do we start? Yes. So this is heat gained. Heat gained is equal to heat lost. It's got a space, right? Yes, heat gained is equal to heat loss. Like heat energy gonna calculate ion Q is equal to MC change in temperature, right? Given Q ya rona. Okay, yeah, step by step on it. This is our Q. This is how we calculate Q. So heat gained is equal to heat lost. Yes, heat gained G is equal to heat lost L nyana yo a ke subscript nyana ha ke batla gore re kgona go lemoga gore go iragaleng ya ke then heat gained kana mme heat yana formula ra teng ke MC change in temperature ke ene Q ya ke le ka kwano ke MC change in temperature. Ke se ka tsa step by step ga ka tla gore ke le lathegela ya mo ha re tsena ha berere go akana metsi a ka gainang heat ka he ka nte go a re lebelele metsi a mo go 85 a mo go 25 temperature ya go 25 ya go go godimo ena metsi a temperature ya go kae go tlase go ra final temperature is less than this but is more than this. Go ra metsi ya 100 gram a bika a kona gainang heat a kra na le kwa tlase ka temperature ra so go ra 100 gram tsena ka kwana so go ra 100 gram okay go aga tere ba teng ka temperature final temperature. Okay guys, go ro ira ka gram kana ka eng ka kg a go matter because these values are going to cancel out. They are going to cancel out at the end. Yes, I go talk a lot of changes it to kgs here. I go talk. Yeah, no, C is equal to 4,200 specific heat capacity of what? Of water. This is water. So tota I go talk a lot of o tsenye value. Ke ta tsenya C, ke ta bona receiver teng wa go cancel. You don't need this value. Sometimes they can even leave it out. Then get times C. Then Hana worry open brackets. I get close bracket. What M? This M again give me at 300. 300 gram times C. Kinsiki C. Open brackets. Then close brackets. Hana temperature relay ya guy. Ya go dim. I get ya go dim temperature. So our final temperature T is gonna be bigger than 25. So our T minus 25. Kakone temperature in mo 85. Or mo 300 gram mo meeting temperature ya gore ya drop. T wa drop. Ha T wa ga go godimo. I get final temperature double go godimo. Metsi a go gena temperature a go lose temperature so ke 85 minus T. Ra bona ke yes. So ha go ntsana go ra mo ke 100 C a ditse ke tsa re itse algebra ro theng go hela sente. Go ra C we can divide both sides by C. Kana are dividing both sides by 100C. Divide both sides by 100C. I can allow the brackets are right there in the divide both sides by 100C. This cancels this out. I can cancel C cancels C. 100 cancels 100 plus 3. Keep 3 Wamana wo C level ni just cancels out is so how get T minus 25 is equal to 385 minus T. then open brackets, 3 times 85. 3 times 85 ke bona 255 minus 3t. Okay, ka kwano gane ke t minus 25. Okay, ya magantsana, what do we do? What do you re batla gore ke like term ye ka ye go go mo hela. Okay, so ka kwano ra re go mo ke minus t. Okay, magire yana ehe go ra gore ra go ira yang, let's add 3t both sides, plus 3t plus 3t. go ra gonna ya, this one cancels out, this cancels out guys. How was I 2, so 255. Then here gonna t minus ke plus r plus a agree plus 3t r tseng re ba pisense e tshwanang guys, 3t minus 25. ha re tsena ha re decide go ira eng gape go tsa go add 25 both sides, gore 25 yo apota ka ha plus 25 plus 25. This cancels out, then we are left with 4t. 4t, 255 plus 25 is 208. 208. And then what do we do when we get here? Because we want to solve for t, we divide both sides by 4. This 4 cancel this 4. 4 into 4 here, that is 1, right? 4 into 280 is 70. This is 70. Therefore, t is equal to 70 degrees Celsius. This is T. This is the final temperature. So, oka emisa this video, wale ka go kopola this question, or wale ka go solve again as a practice, or wana rota wana 70. Hela ka re rilo wale ka go sala di step tse morago he. Dipotso di tla nna ya harologana, but the concept is one. Heat gain is equal to heat lost. Or heat kana mingi Q is equal to MC, change in temperature. Ba ka nna ba taba re tshipila thatso mo metsing be ba go ha C rona ha ne re le ka re C wa tshwana, it cancels out. Gona le botse re ta irang C wa sa cancel ka re mo ngwe ya bele ile metal mo ngwe ile metsi. Okay, ya mara hele gone ha re ta tswella ka more questions in the next video. Thank you.